So imagine sitting at your desk, editing this massive cinema quality video.
Right.
You move your mouse, and the cursor just glides instantly. You type, and the letters appear with absolutely zero lag. But the actual computer you're using isn't even under your desk. It's like sitting in a locked vault 6 miles across town.
Which is pretty wild to think about.
Right. Welcome to today's deep dive. We are looking at a highly specific, heavy-duty piece of technical hardware from HDTVSupply today. It's the Smart-AVI P2P-KVR300 IPGard receiver.
Yeah, that's quite a mouthful. And the price tag is a pretty hefty $721.65.
Exactly. So today we're going to figure out how this little box basically erases physical distance. Because normally, if you just string a standard copper cable across a big room, the signal just degrades.
That's
right?
totally. You get glitchy video or dropped mouse clicks. Physical resistance is a real problem. But this receiver takes your entire workstation setup, your flawless 4K video at 30 hertz, analog audio, transparent USB 2.0, and throws it up to 10 kilometers away.
Wait, 10 kilometers? That's massive.
It is. And it does it without losing a single pixel.
How does it physically manage to push a signal that far without it just completely dying?
Well, so it bridges your standard data to single-mode fiber optics. So instead of pushing those electrical pulses through standard copper wire, it translates your workstation data into light.
Oh, wow.
Yeah, and light can travel through those fiber optic glass tubes for miles without any noticeable degradation. It goes 100 meters over standard CAT cable, sure, but single-mode fiber is where the magic happens.
Right, so it's essentially turning my mouse click into a photon superhighway.
Exactly.
But I have to ask, who genuinely needs a 6-mile-long invisible extension cord? Like, is this just for controlling a secure server across some massive corporate or government campus?
That's exactly it. It's heavily driven by military, government, and large enterprise operations. In fact, this device is actually TAA compliant.
Which means what exactly?
It just means it meets the really strict manufacturing rules required for secure U.S. government purchases. So think about a high-level intelligence facility, right?
Yeah, you absolutely cannot have sensitive servers sitting out in an open office.
Exactly. Someone could accidentally spill coffee on them, or worse, just access the hard drives. So you lock the actual brains of the computer in a heavily guarded, climate-controlled bunker.
Ah, okay. But the analyst still gets to use the machine from their desk way across the base.
Precisely. They get the full, uncompromised workstation experience, while the physical hardware remains perfectly secure.
Okay, but here is where I get kind of hung up. Sending that much high-quality visual data, plus constant USB inputs over miles, the lag should just be unbearable, right?
You would definitely think so, yeah.
Because I'm looking at the specs here, and it claims to use ultra-low latency JPEG 2000 compression, and I have to push back on that. JPEG.
I know how it sounds.
Like the blurry photo format we used on the early internet, how is an old photo standard powering a modern zero-lag video feed?
It sounds totally counterintuitive. But JPEG 2000 and the professional AV world is a completely different beast. It uses this thing called wavelet compression.
Wavelet compression?
Yeah. So instead of trying to shove a massive raw fire hose of 4K pixels down the network line, which would, instantly clog the system and cause lags
Right, obviously.
it breaks each video frame down into mathematical waves. It essentially prioritizes the visual data the human eye actually cares about, and it packs it incredibly efficiently.
Oh, I see. So it's not trying to blast the full fire hose all at once.
No, not at all.
It's intelligently sipping the data, frame by frame, so fast that my eye just perceives a perfect, continuous video stream.
Exactly. It prevents the network bottleneck, which is the actual cause of lag. And it does this heavy mathematical lifting continuously with an insane reliability rating.
Wait, what's the rating?
Well, they list the mean time between failures at over 135,000 hours.
Let me just do the quick math on that. So 135,000 hours, that is over 15 years of this box running nonstop without breaking down.
Right. It is quite literally built to never be turned off. It even handles all the background communication you don't normally think about, like ED learning.
Okay, what exactly is ED learning doing?
Basically, it's a digital handshake. When you plug a monitor into a computer, ED is just the monitor telling the computer, hey, I'm a 4K screen, send me this exact resolution.
Gotcha.
But because the computer is miles away in a vault, this receiver mimics that handshake locally. So everything just remains instant plug and play.
Wow.
Yeah, and it's super adaptable. If you add a separate gateway device, network administrators can use a web interface to route hundreds of different users to hundreds of different servers.
Like a massive digital switchboard.
Exactly. It switches between direct, matrix, and Savigate modes to these really complex multi-user environments.
So we are looking at far more than just a pricey adapter here. It's a real enterprise-grade bridge that solves a massive physical security problem just by translating our work into light and mathematical waves.
It really does completely decouple the human from the hardware.
Which leaves you with this final thought to ponder. If hardware like this can perfectly mirror a 4K workstation with absolutely zero lag from over 10 kilometers away, how will fiber optic AV infrastructure reshape the concept of the traditional office in the next decade?
That's a great question.
Right. Like, could the physical computer hardware sitting under our desks eventually just disappear entirely, leaving us with nothing but a screen and a flawless connection to a machine we never even see?